Hello everyone, I'm Archit and today we'll be learning Dijkstra's shortest path algorithm. So let us first understand the problem at hand. So basically we are given a graph that is weighted and undirected, and we are given a source node, and we want to calculate the minimum distance from this source node to all the other nodes in the graph. So we'll learn this algorithm with the help of an example. So let's say this is the graph that has been given to us and A is our source node. So there are multiple distances possible from A to any other node, let's say E. So this is a path and this is a path. So a brute force approach would consider traversing through all these paths and then selecting the minimum path. So what we'll do instead is we'll use the Dijkstra's algorithm, which is essentially a greedy algorithm. So I have divided all the nodes into two sets, set S and S prime. So what are these sets? Set S is the set collection of all nodes for which we already know the shortest path from the source, and S prime is the set of all nodes for which we don't yet know the shortest path. So since we are just beginning the algorithm, all the nodes are present in set S prime. We'll eventually move them to set S. So let's begin. So basically, let's consider the distances. So since A is our source node, its distance from itself would be 0, and all other distances are infinity. So now what is the first step of the algorithm? The first step of the algorithm is consider all these nodes in set S prime and select the node with the minimum cost. So since A is the node with the minimum cost, we'll move this from set S prime to set S. Now once we have moved this node from set S prime to set S, we'll update all its neighbors. So what we'll do is we'll calculate the new distances for the neighbors. So what is the new distance? New distance is the cost of the parent plus the weight of the edge that connects the node from the parent. So new distance of B would be 8 plus 0, that is 8. So since this is lesser than infinity, we'll update this. This is 8. And we'll also store the parent of B as A. Similarly, we'll do this for other nodes. So once we are done with exploring all the neighbors of A, we'll again move to the first step, that is we'll consider all the nodes in S prime and we'll see which of them has the minimum cost. So here it is C. We'll move C from S prime to S. So and again consider all the neighbors of C. Note that here A is also a neighbor of C, but we don't need to update the distance of A because A is already present in set S. That is, we already know its minimum distance from the source. So we'll consider all the other neighbors. So now consider B. So its new cost would be 2 plus 7, which is 9. So now the algorithm says that since the new cost is greater than the original cost, we don't need to update this. Now consider D. Its new cost would be 2 plus 1, which is less than 4. So we'll update this. So see here that at each iteration the cost is being reduced to a lower number. So this is what our greedy algorithm does. At each step it will try to find the lower bound to the cost. So once we are done with, okay, this is left. So this would be 2 plus 3, 5. 2 plus 9, 11. So we are done with all the neighbors of C. We'll again come back to this step. We see that D has the minimum cost of 3. We move it from S prime, move it to S, and then consider all the neighbors. So this is covered, this is covered, this. Its new cost would be 8, which is less than 11. Just update it. So now we are done. Consider B, E, and F. E is the node with the minimum cost. Move it. And consider all the neighbors. So this would be 5 plus 2, 7. Comma E. Yeah, we are done. So now we'll consider B and F. So B is at a cost 7. We'll update this. And now since there's no connection from B to F, F is the only node left in S prime, we'll move F from S prime to S. So now essentially we have found the minimum cost from A to all the other nodes. So basically, as you see that Dijkstra's algorithm is a greedy algorithm. It extracted the minimum cost nodes at each step and moved it from S prime to S and updated the distance of the remaining nodes only if the distance was lower than the already existing distance. So now let's say we also want to find the path of the, let's say from A to E. So we just go to E and see its parent. Its parent is C. We go from E to C. Its parent is A. So we move from A. So since we have hit the source node, so basically we have got a path which is from A to C to E. So this way we could also find the minimum path between the nodes. So that was our Dijkstra's algorithm. Thank you.